We are still in Unit 1. We are still doing exponents. We are doing day 8, correct?
Yes.
Okay. We are still doing scientific notation, but this time we're doing multiplying. So we are going to multiply scientific notation. Here's our first couple questions. Is it in scientific notation? If no, put it there. This is the first thing that we're going to have to do, is be able to say, is it in scientific notation? If it's not, how can we change it and make it scientific notation? So here's number 1. 34 7/10 times 10 to the 4th. So Caleb, 34 7/10 times 10 to the 4th. Is that scientific notation? No. Be a little bit more confident.
No.
No. Who can help him say why it's not in scientific notation? David.
It's over 10.
What's over 10?
34.
34 is larger than 10. Our first number must be at least 1, but less than 10. So now we can say no. But now we have to put it into scientific notation. To do that, we're going to rewrite our number. 347. Where the decimal is, that's where I'm going to start. Times 10 to the 4th. So which way am I jumping? To the right or to the left? To the right. So 1 bunny hop, 2, 3, 4. In those spaces, we're going to put zeros. So now I've got 347,000. Is this scientific notation? No, that's standard form. So where will I have to put my decimal? Go ahead, Isabel. Between the 3 and the 4. So this will really be 3 and 47/100 times 10. 1, 2, 3, 4, 5. Notice what happened. I moved it over 1. I added 1. Let's try another one. See if it works for another one. 89 2/10 times 10 to the negative 4. Ooh. Again, scientific notation, Evan?
No.
Why not?
Because,
We're on number 2.
yeah.
Why
No,
not?
it's not, because it's over 10.
What's over 10?
The 89.
89 is larger than 10, yes? So now I'm going to rewrite my number. So we're going to say no again. I'm going to rewrite my number. 892. Where did the decimal start in this problem, though? Between the 9 and the 2. So I have to jump negative to the left 4. 1, 2, 3, 4. And I put a decimal. So now I have 0.00892 tenths, hundreds, thousands, 10,000s. So I have 892 100,000ths. Where should the decimal be? So I should have 8 and 92 hundredths times 10. Well, 1, 2, 3. The negative third. So remember, we added 1. Negative 4 plus 1. If we come to our number line, negative 4 plus 1 gives me a negative 3. So we added 1. Huh. Okay, try this one on your own. Tell me what you get. 452 times 10 to the second. Be careful. You need to know where the decimal starts. I'm telling you immediately that no. It is not in scientific notation. So you need to think about, where is the decimal? Where does it need to be? Can I write it in standard form? Those are all important things. See what's happening. So I would start off by writing it in standard form. Okay, here we go. Simone. In 452, just 452, where's the decimal?
Between the 4 and the 5.
So if I tell you, here's my number, you're going to wear this on a jersey, 452. Does your jersey have a decimal between 4 and 5?
No.
No, so where would the decimal be in the number, whole number, 452?
Before the 4?
Not quite. You're going the wrong direction. What do you think, B?
Be at the end.
It'd be at the end. So it would really be 452 and then a decimal point. Okay? So now to change this to standard form, it's telling me to jump to the right how many places? 2. 1, 2. So this number is 45,200. Now let's go back to you, Simone. To change it to scientific notation, where does that number have to be, or the decimal have to be? Between what two numbers?
4 and the 5.
4 and the 5. So I know it's going to be 4 and 5 tenths times 10 to the 1, 2, 3, 4. So this time, we moved the decimal how many places? 1, 2. How many numbers did we add to it? 2. Okay, we're adding numbers to it. Everybody with me? Okay. One times 10 to the 4th. The number in front of the times symbol, in front of that x, is what we call the coefficient. Okay? So the number in front of the times symbol is our coefficient. Then we've got the times 10 to our exponent. When we multiply, multiply the coefficients. So that's one step. We're going to multiply the coefficients. The second thing we're going to do, keep the base of 10 and add the exponents. So this is still the exponent rules. If we're multiplying, we keep the base, we add the exponents. And you're like, Mr. H, I'm not quite sure yet. You will be. It's all right. Let's move this a little bit. Does everybody have this over here copied down? I can erase this. Bianca, if you need to move up, honey, please do so. I don't want you to hurt your eyes by squinting. So here is how you're going to see scientific notation getting multiplied. So here's our example. You might see 2 times 10 squared in parentheses, and then another sign of parentheses that says 3 times 10 to the 6th. Everybody still with me so far? What is the coefficient, and I'll go back to this color, in my first problem, or in the first scientific notation? What's my coefficient here? 2. This is my coefficient. What's my coefficient in the second portion, Isabella? 3. So we're going to come back over here. multiply the coefficients. Can we see this over here? No. There we go. Multiply the coefficients. So I'm taking 2 times 3. We can do that. Yes? Grego, what's 2 times 3?
4. No. 6.
That's the next number. Yes, 6. So my coefficient is 6. We're still going to have times 10 to the something because these are like bases. The 10s don't change. Keep the base of 10. I did. Add the exponents. 2, 6. What's my exponent going to be?
8.
And we're done.
Whoa.
That's it. It is not hard. Multiply the coefficients, keep the base of 10, add the exponents. Everybody trusts me still, right? Not hard, yeah? Okay. Try this one on your own. I'm going to make it a little bit trickier. 3 times 10 to the negative 3 times, actually let's go times 3 times 10 to the 5th. So I'll give you a minute. Try this one. A little bit trickier. You will have calculators for your test. But right now I'd like you to try without the calculators because I'm not going to give you any kind of math that's so hard that you can't do by looking at the number line. Saw your hand up there. No, no. Okay. So, Brooklyn, what are my coefficients? 3 and 3. Why does everybody sound confused? 3? Come on, Brooklyn, you're smart. Have confidence. Say 3, Mr. H. Like you can be like, you jerk. It's 3. Like, I mean, I'm kind of a jerk, but so it's 3. My coefficients are 3. So we're gonna do 3 times 3, which is 9, times 10, because we're going to keep that base. Now, without a calculator, you might have a little bit of trouble with this. Negative 3 and 5, because we're going to add the exponents. If I have a lot of trouble, go to an underline. Here's negative 3. If I'm going to add 5, that's to the right. 1, 2, 3, 4, 5. We end up at? Positive 2. So I get 9 times 10 to the second. Questions there? Now, the way that this will say on your test, multiply and keep in scientific notation. That changes it. Multiply and keep in scientific notation. Let's go 3 times 10 to the 7th. Actually, yep, 3 times 10 to the 7th times 5 times 10 to the 2nd. So 3 times 10 to the 7th times 5 times 10 to the 2nd. I want you to do 2 things. First, get it done on your paper. Whatever you think it is, keep it in scientific notation, talk it over, see if you can come to a conclusion with the person next to you. Use our key words. I agree because. I disagree because. And then use mathematical language. Give them a try. So multiply the coefficients, add the exponents.
Has everyone conferred with their neighbor? All right. How many more seconds do you need to finish it up? Sounds to me like you guys are done. All right, let's look at this. Okay. Voices are off. We're done talking. Somebody walk me through this. Shh. Give me directions on how to solve this because truthfully, honestly, this is my first time ever doing this, so I need to have directions, Mr. Smith.
Okay, you have to multiply the coefficients.
Oh, you know what? We're going to get really good directions here, so we're going to listen. Go ahead.
You have to multiply the coefficients. So it's
Okay, so what numbers are the coefficients?
The 3 and 5.
Nice use of mathematical language with a coefficient. So I have to multiply the coefficients. 3 times 5 is, I do know this, that's 15. Okay, thanks for the good directions. Go ahead,
Oh, okay.
continue.
And then you have to keep the base, so it'd be times and then 10.
Times 10.
And then you add the exponent.
Okay, so I see that the exponent here is 7 and 2. So I'm going to add 7 plus 2, and that is 9. All right. Did you confer with your neighbors? Okay. Do you and your neighbors have the same answer that Brendan instructed us to get? What
Okay.
questions do you have?
Oh, I do. I have a huge question.
Okay.
That's my favorite mistake. What, Megan? What's larger than 10? Oh, wait a minute. It's larger than 10.
Wait.
So, what do we have to do, Megan? Okay, guys, we're listening to Megan. Megan, go. Where? Okay.
So I'm just going to add it. I'm like, okay, I'm good.
Now what do we do with the exponent, Megan? Don't tell me. Tell Mrs. Armstrong.
I add one?
Yes, ma'am.
To the 9 to make it 10.
You do?
Yes.
Add one so you can.
I knew that.
Okay.
So we don't have to look back.
So Mr. H, when I look at that, that almost seems backwards to me.
Yes, I know, and that's when we were doing those examples. As long as we're moving that decimal, whichever way, so it's from the negative, we're still going to add 1. So if it's -4 and we move it 1, it's going to be -3. If we add 1, we're going to go from 9 to 10 because what's happening is we now have to move it over 10 places to get to the same answer if it was 15 times 10 to the 9th because there would be 9 zeros. Well, now it's 10 because we need to move it once over to the 5 and then still have 9 zeros.
Okay.
Let's do another one. So,
I get it, but I think
we're going to do a couple.
Kind of weird.
we'll do some more, right? Yeah, because faces are like, let's do some more.
Okay, here we go.
I agree, let's do some more.
I agree, let's go 6.
So we've got 5 times 10 to the second, 6 times 10 to the third, and 4 times 10 to the negative third, 7 times 10 to the negative first. So these two problems, keep them in scientific notation. So not only do I want you to multiply, but then keep them in scientific notation. Remember, just like the examples that we started off with, if you need to write it out into standard form and then convert it back to scientific notation, do so. That's why we did those problems. Is it in scientific notation? No. How can we get it there? We did several examples like that to start the lesson.
Or do you still add if it's negative?
Yes, ma'am. Let's see if we're at -3. And we lose another dollar because it's adding another negative one where we at. Hmm? We can hear you. So, yes.
That's the only one.
-3 plus.
A -1 is going to be. Okay, so listen. I know we're not arguing, but we're talking, which is great. Okay, Jackson. Number 1. What am I going to multiply? What do we call the 5 and the 6? The what? Coefficients. So 5 times 6 is 30. Times 10 to the, what do we do with the exponents? Add them. Now, let's write this out so that you can see what's actually happening. Because Ms. Armstrong said, hey, there was some looks saying, I don't remember doing this. We did it at the beginning of the lesson. So 30 times 10 to the 5th. Where is my decimal in the number 30? Behind the 0. Good, David. So I'm going to go 1, 2, 3, 4, 5. So this is 3, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 3 million. Where does the decimal need to be? Between the 3 and the 0. So times 10. So if it's here, 1 bunny hop, 2, 3, 4, 5. Oh my gosh. We've added 1. Still with me? Okay. Let's do number 2. Maya, what 2 numbers am I multiplying?
The coefficient.
Good.
4 and 7.
Good. My coefficient's 4, 7. That gives me 28 times 10 to the, now we have -3, and we're adding a -1. So, it's really like saying -3 minus 1, so which way are we going to go? To the right or to the left? To the left, so what is that going to give me? -4. Is this in scientific notation? Whoa, hands. Hands. Grego. No. So let's say I'm having trouble with this. I don't know that I'm just going to add 1. I need to see it. So now I'm going to go 28. Where is my decimal right now? Where's the decimal right now with the number 28? Behind the 8. So now it's -4. 1, 2, 3, 4 and a decimal. So really, it's 0.0028. Where does the decimal need to be? Go ahead, Maya.
Between the 2 and 8.
So that's 2 and 8/10 times, well, let's see, 1, 2, 3. Is it going to be positive or negative? -3. Wait a minute. Let's take a look. Wait. We put the decimal here. What did we do to our exponent? We added what?
1.
1. -4. And I add 1 to it, gives me -3.
Wait, why'd you go back?
Because you're adding a positive, not a negative.
Yeah, you're adding positive.
Positive always goes which direction?
But then
You're
you
adding
added 3 and 1. You went.
Wait. Say it again. So we had a -3. I owe you $3. Okay, that's what negative means. I owe you $3. I owe you $1 more. How many dollars do I owe you?
$4.
$4. Now I've given you $1. How many dollars do I owe you now?
3.
That's adding the 1 to it. Yes, ma'am.
So you wouldn't add negative, so positive?
No.
So I'm going to actually write out the addition problem. okay? Because there are 2 points right here that we're getting confused. The first one is that we are adding negative exponents. And Mr. H showed us this on the number line. But, so in my mind, I start with a -3 on the number line. When I add a negative number, we go in the negative direction, right? So when we add a -3 plus a -1, we end up at -4, okay? I do understand how this looks backwards because in my brain it looks backwards too, right? Because when we learned this initially, we're like, oh, if you go to the left, we're going negative. Oh, if you go to the right, we're going positive. But that doesn't apply here. If this is confusing to you, you need to come over and actually do the conversion, okay? And work out the problem. Because you can't just say, oh, go to the left, it's negative. Oh, go to the right, it's positive. Because that doesn't apply in this case, okay? Does that make a little more sense?
Yeah, because you're adding a positive one to the negative one.
There you go. Okay.
Okay, one more set of problems. You're probably not going to finish them before you leave, so you need to make sure that you write them down because this will be your homework. So write them down. Just 2 problems. Just 2. Here we go. Number 1. 5 times 10 to the 6th times 1 times 10 to the 7th. And number 2. 3 times 10 to the -3rd. 8 times 10 to the -5th. So those are your 2 homework problems. You can get started now. We will go over these tomorrow. So again, your 2 homework problems. Got them? Good.